Hello and welcome. This is a lesson on atmospheric pressure. Get ready to learn, not get squished. Did you know? Air is made of matter and takes up space. Air exerts pressure on everything. Pressure varies by two things: temperature and altitude, and causes wind. Okay, let's look at that. If you have low pressure here and high pressure up here, you got a lot of air molecules stacked up here, and they want to go to a lower pressure. So you always go from high pressure to low pressure. And then the balancing of this out is called wind. Now, the reason you have highs and lows is because this is water, this is land. Cool air travels towards warm air over the land. So you have the balancing of the air pressure from high to low, always high to low, causes wind. So that's where wind comes from. Why is it important to know about atmospheric pressure? Well, knowing about air pressure lets us predict the weather. If you have low pressure, there's a chance of rain. If you have high pressure, it's fair skies. Lower air pressure means a greater chance for rain, and higher the air pressure means clear skies. We'll talk about why later. Okay, air pressure is the measure of the force of a column of air molecules that is stacked up around 100 miles to space. If you go like this, that's about 1 inch square, and then picture a column that goes from ground level or sea level up to space, and all those air molecules are stacked up and they're pulled by gravity towards Earth. And the pressure is due to the gravity acting on the stack of molecules. So that's where the air pressure comes from. It's all these air molecules stacked up one on top of another. Now you can measure this. The air pressure is 1 kilogram per cc, or 14.76, give or take, pounds per square inch. That's that 1 square inch thing I was talking about. And you can measure this. At sea level, nearly a ton of air is pressing on you. You take the number of square inches of skin you have, and that's where the air is pressing. You can feel the change in air pressure when you go up a mountain or you take off in an airplane. Your ears pop to balance out that pressure on the inner ear. And it's measured with a barometer, a barometric meter. And here's how one type works. There are several different. But you have a box here. Think of a pizza box. And on the top of that box, you have a spring and some levers. And if you squish the box because of higher air pressure outside than inside the box is sealed, this dial is going to move. So as you squeeze it, the dial is going to go up with higher air pressure. And it's that simple. This is a barometer, a meter of barometric pressure. Buoyancy. Now, heavier than air balloons can float in the air due to differing pressure. these things, they're made out of nylon and steel and or aluminum, and they carry people, and they're obviously heavier than air, but yet you can float because they're filled with air that is heated. They have big burners that send heated air up into the balloon. Now, heated air takes up less space than colder air. Therefore, there are less molecules in there, and it actually floats in a sea of air the way a boat does in the ocean. Same idea, except instead of being liquid, it's a gas. Now, weather. High pressure brings clear skies. And that's because high pressure air holds less water vapor. Gives you that blue sky. Low pressure brings cloudy skies because low pressure air means there's more room for water vapor. So you get clouds. High pressure, clear sky. Low pressure, cloudy. Now, remember, air pressure changes based on temperature also. As you go up a mountain, here are the mountains down here. As you go up a mountain, the temperature goes down. The air pressure changes. That also goes down. Air pressure goes from sea level, 14.76 pounds per square inch, to when you get out here, out of the thermosphere into the exosphere or space of 0. Now, the atmosphere has several different layers, and different layers protect us from radiation. And the layers of the atmosphere are separated by the temperature shift. In other words, the temperature goes down as you go up in altitude in the troposphere, and then it changes, and that's a different lesson. But pretty much most of the air is in the troposphere, so the air pressure there is the highest. Now, why aren't we crushed by all this air pressure? Remember, there's about a ton pressing down on you right now. Well, people are mostly water, and water is very difficult to compress. And the air presses on not only the top of us, but underneath and the side and the front. So it presses on all parts of the body. Now, high pressure and water vapor. The air molecules are mixed with the water vapor, and high pressure only holds only a small amount of water vapor. So when you have these high pressure areas on the map, it's clear skies. Now, low air pressure and water vapor. The air molecules, again, are mixed with water vapor, but because it's a mixture, the amounts vary. Low pressure holds a higher amount of water vapor because there are more room for water molecules because there's less air molecules. It's a low pressure area. And you'll see these lows are associated with some kind of precipitation, rain, snow, sleet. So whenever you see a low, you're looking at cloudy skies. Highs, clear skies. Now, water in the air is air molecules are mixed with water vapor. Water vapor is invisible. Clouds are actually small droplets held in the air by wind. And the lower the pressure, the more water molecules or droplets that are frozen can be held. So, why is it important to know about atmospheric pressure? Knowing about air pressure lets us predict the weather. Lower air pressure means a greater chance for rain, and higher the air pressure means clear skies. Get yourself a barometer and you can predict the weather. There's your lesson on atmospheric pressure.